Somewhere in the vastness of space, there may be other places where life began. Different skies, different suns, yet the same question: are we alone? In this video, we'll explore how scientists search for life beyond Earth, where life could exist, how we detect those hidden worlds, and what the next generation of telescopes may soon reveal. Every story of life begins with distance. Not too close to a star and not too far away, a fragile zone between fire and ice. Astronomers call it the habitable zone, the region where liquid water can exist. Earth sits right in that balance. A few million kilometers closer, and our oceans would boil. A few farther, and they would freeze. It's cosmic luck, but also physics in perfect equilibrium. The same principle guides our search among the stars. Find the right temperature, and you might find the conditions for life. We can't simply point a telescope and see another Earth. These planets are too small, too dim, lost in the glare of their stars. So astronomers became detectives. They measured tiny dips in starlight when a planet passes in front, the transit method. They watch a star's slight wobble as a planet's gravity tugs at it, the radial velocity method. From these invisible clues, we can now detect a planet's size, orbit, even hints of its atmosphere. It's science that reads the light itself, turning darkness into data. The first confirmed planet beyond our solar system was discovered in 1994. Today, we've found thousands of others. Some orbit stars like our sun. Others circle smaller red dwarfs, where a single day can last for weeks. One of them, often called Earth's older cousin, lies about 1,400 light-years away, a rocky world that may once have had oceans. Another, part of a nearby system with 7 rocky worlds, could hold water beneath thin clouds. They're distant, yet strangely familiar, reminding us that Earth may not be unique. Not every habitable world looks like ours. Some are covered entirely by oceans. No land, only endless blue. Others are locked to their stars, one side scorched in eternal daylight, the other frozen in darkness. Among them are worlds like the steamy planet Gliese, a place wrapped in thick clouds where light barely reaches the surface. And a world astronomers simply call Kepler's ocean planet, thought to be covered by deep boiling seas. They remind us that life might not need an Earth at all, only chemistry, energy, and time. Beyond planets lie the moons, worlds that orbit worlds. In our own solar system, Europa and Enceladus hide oceans beneath their icy crusts, kept warm by tidal forces from their giant planets. NASA's Dragonfly mission to Titan will explore its methane seas and orange skies in the 2030s. If life can survive there, in liquid other than water, then the possibilities multiply across the galaxy. Moons could outnumber planets, and each might be a tiny cradle for life. The search is just beginning. The James Webb Telescope has already glimpsed the atmospheres of distant worlds, reading their light for signs of oxygen, carbon dioxide, and water vapor. But even Webb is limited. It reads light, but cannot yet see another Earth directly. That will soon change. NASA's next-generation observatories, known as LUVOIR and HabEx, will be up to 100 times more powerful. They'll isolate the faint glow of a planet beside its star and study its spectrum for the chemical fingerprints of life. Europe's PLATO mission will find thousands more worlds for them to explore. Each new telescope extends our vision, turning imagination into observation. We may not yet know if life exists beyond Earth, but we are no longer just wondering. We are looking. In every star's light, in every faint shadow of a passing world, we're searching for reflections of ourselves. And perhaps one day, one of those reflections will look back. If you enjoyed this exploration, subscribe to join future journeys across the universe. And tell me in the comments, where do you think we'll find life first?